So,
There's Weekend, what's up?
hey guys.
I got
All right. So if I have sine of, this is 2 sine 30, that's like saying 2 sine of theta. Now, suppose we go back to our sine of 30. That we said was a half, okay? Now, suppose now I multiply the 30 by a 2. What is that? That's now sine of 60, which is how much? Root 3 over 2. So what I did here is I have sine of 2 theta. Okay, so do you see the difference in, what happens to where, like, depending on where the 2 is placed? Yeah. Yeah? So when you have sine of 2 theta, it's a different angle entirely. Okay? And so if I start with 60 degrees, sine of 60 degrees, and then I do sine of 2 theta, how much is it then? Sine of what? If I start with sine of 60 degrees? Sine of 120, and so now that's a whole other quadrant too, right? So like a whole other situation. So what we're going to tackle today are double angle identities. These are double angle identities. Sine of 2 theta, okay? Well, the identity is that that's equal to 2 sine theta cosine theta, all right? So to evaluate sine of 2 theta, you can actually use the single thetas to evaluate it, okay? Now, take a look at cosine of 2 theta. You have 3 variations of cosine of 2 theta, okay? Cosine of 2 theta can equal this, or this, or this. Which one's better? They're all equally as good. Which one do you use? It depends on what you have to work with. All right, so I have 3 variations. Tangent is always the rebel. It's a whole thing of its own, right? Again, anything in section 5, you don't have to memorize. You will be provided with a sheet of these on the test, okay? You just have to know what to use when. Okay, so, hi, hello.
Oh my God.
Okay, so we have
We're back.
we have sine of theta is 3 over 4 on the interval 0 to 2 pi. We want to find 2 theta, sine of 2 theta, cosine of 2 theta, tangent of 2 theta. Usually you will be given enough information to also figure out what quadrant this is in. For this problem, we're just going to assume it's in quadrant 1. Okay? So,
Usually they'll give the qualifications.
right.
They'll be like, oh, well, this is that.
Right. Usually they'll say, okay, sine of theta is this, and then cosine of theta is positive, so you can figure out what quadrant. Right now, you're not told the quadrant, so I told you. Okay. We need to find sine of 2 theta, cosine of 2 theta, and so on. Well, for each of them, sine of 2 theta, let's say, right? What are the ingredients? We need sine of theta and cosine of theta. Well, I have sine of theta. I don't have cosine of theta. So first, I'm going to use a Pythagorean identity to find cosine of theta. Okay, so all right, so sine squared theta, you guys are experts on this now, plus cosine squared theta is equal to 1.
Yeah.
Sine squared theta is 9 over 16. Plus cosine squared theta is equal to 1. Subtract 9 over 16. Cosine squared theta is 1 minus 9 over 16. So now cosine squared theta is 7 over 16. Cosine of theta is plus or minus root 7 over 4. But I just told you we were going to work in the first quadrant, so we're going to take positive root 7 over 4. Okay? Okay. Now that I have cosine and I have sine, I have all the ingredients I need to find the rest. Okay? So, first off, I want to find sine 2 of theta. Okay. Well, there's only one identity there. It's 2 sine of single theta, cosine of single theta. 2, what's sine of theta? Yep. What's cosine of theta? Yay. Here, 1, 2 cancels with one of the 4s, so I get a 2 here. 3 root 7 over 8. Good. That's sine of 2 theta.
Why would you want to find that? Like, what does that actually mean?
So suppose you need to find sine of, suppose you want to find sine of an angle, right? But like,
It's just bigger than.
right, suppose like theta is a special angle, but 2 theta is not, and you need to find,
Oh. Okay.
right? Yeah. And then next, number 3, let's find cosine 2 theta. Okay, so for cosine 2 theta, you've got a whole choice, right? You can use any one of these, right? You have both cosine and sine, so you can use this one, or you could just use this one, or you could just use this one. So which one do you guys want to use?
Well, I don't know.
The third one. Okay, Mayan was first. She said the third one. Let's do the third one. 1 minus 2 sine squared theta. So this is 1 minus 2. What's sine squared theta? 9 over 16. So this is 1 minus 9 over 8. And this is how much? Negative 1 over 8. So cosine 2 theta is negative 1 over 8. Next.
It can be negative?
Yeah, it can be negative, remember? Because, so,
I thought we were in the first.
yes, theta, that's such a good, thank you for asking that. So suppose theta is 60 degrees. You're in the first quadrant, right? How much is 2 theta? Double, which is how much? 120. So now you're here, and cosine over there is negative. Right?
So it's like a double angle can end up in a different quadrant than it started. Won't it
It
always
only
end up in a
be for
different
one of the
quadrant?
sides. Like if it's
Not if it's 30 degrees.
Very crazy.
If it's less than
yeah,
45
yeah.
degrees, it's going to be in the six.
Yeah.
See? Oh my God. And people say math isn't fun. Like, oh my God. Like, seriously, look at that plot twist. Okay. I don't know what I would do if it wasn't for math. Like, seriously, what would I work at? Like, nothing could be as satisfying. I mean, I meant like what? Like be an engineer? Okay. So next, I need to find tangent of 2 theta. Now, here's a secret. Don't tell anybody. You can use this, right? But don't ever forget what you learned at the beginning of the chapter or even last chapter. What's tangent? Is tangent sine over cosine?
Yeah.
Sine squared over cosine squared is tangent squared. Sine 2 theta over cosine 2 theta is also tangent 2 theta. So for tangent, you can either use this or you can say this is equal to sine of 2 theta over cosine of 2 theta. Please be careful. If this is a 2 theta, then those also have to be 2 thetas. So now this is 3 root 7 over 8 over negative 1 over 8. This is negative 3 root 7. Okay? And magically, even if you went with that formula, it would have been the same. Okay? All right. Yes.
I was gonna say, if we wanted to find, like for step 3, we have to find cosine 2 theta, we could have just done the cosine squared minus sine squared theta.
Yep, you would have gotten the same answer. Same answer. Okay? Yeah. Okay. So here we go. Now we need to solve this. So here I have cosine 2 theta minus cosine of theta is equal to 2. Remember how in the last lesson we said it wasn't a good, like, it wasn't good when we had different trig functions, like sine with a cosine. We wanted to make it like homogeneous and make it, okay? Same thing here. I have all cosines, but I've got like all sorts of angles. I have 2 theta, theta. That's not good. You want to make all of the angles the same angle, okay? So you want to convert 2 theta into theta. Is there a substitution for cosine 2 theta? There is, right? There's a whole bunch of identities here. So now it makes a difference which one you choose. You have 3 choices. Everything else in the equation is cosine. So it would make sense to use the cosine one. Okay? So we're going to make that 2 cosine squared theta.
Could we use the other one if you wanted? Or no, because that's the only one with just cosine.
Yeah,
Oh.
You'll run into other troubles.
Oh, lovely.
Yeah, so 2 cosine squared theta minus 1 minus cosine theta is equal to 2.
Why do we choose that?
Because the rest of the equation involves cosines. And when I write my new equation, I want it to be homogeneous in all cosines.
Oh, that's okay.
Yeah?
That's it.
Yep, that's the only one that has just cosines. Okay. Now, to solve any equation, this is where some people ran into trouble on the quiz.
Oh, goodness.
You must bring everything to the same side and set it equal to 0. So, subtract 2, 2 cosine squared theta minus cosine theta minus 3 equal to 0. Okay, now we're going to factor. Okay? I like the guess and check. But have you also learned the way to factor where you multiply the 2 to the 3 here? Yeah, and then you add this. Okay, so let's do it that way here, just so I can show you that anything works for anything, right? So multiply the 2 here. You have cosine squared theta minus cosine theta minus 6 equal to 0. Okay? If you like the guess and check better, you can do the guess and check. Yeah, okay? Now, if you factor this, just leave some room in the front of this parentheses here. So it's going to be cosine minus 3 plus 2, right? Is that right? Mm-hmm. But because we took away a 2, you have to add the 2 back. And then you have to just simplify any that can be simplified. So here, this is all good. But here you can divide both of those by 2. So it's cosine theta plus 1. So either way is fine. Use whatever method you like, but please factor correctly. Now, 2 cosine theta minus 3 is equal to 0. Cosine theta plus 1 equal to 0. Cosine theta is 3 over 2. What about that? What about that? Why not? It's more than 1. Cosine can never be more than 1 or less than negative 1. So that gives you no
Is
information.
it just for cosine?
Sine or cosine?
Sine over
Yay, wait, so if you did it on the quiz, was that right?
and tangent.
Allegedly, yeah.
I think I got it right then.
Cosine theta equals -1. I don't know why I'm yelling. It's just so exciting.
Is it just for sine and cosine? Like, do you guys know?
Yeah.
Sine or cosine?
Just those two.
So this is 1, 1, -1, -1. So here I want cosine, the x value to be -1. Where here is cosine -1? X value here at pi. So x is pi. And that's it. X is pi.
Lovely.
It is lovely, kinda. Okay? Okay. Okay. Let's go to some more identities. Sometimes in calculus it's necessary to work with function which are the product of two functions. Like this one, cosine 2x, sine 5x. There's lots of issues here. One is it's two different functions being multiplied by each other. Two is they're not even the same sort of angle. One is 2x, one is 5x, 2 theta, 5 theta. So, all right. These are called, so to simplify these, we need what we call product to sum identities. These are called, why are they called product to sum identities? Because you start with a product, you end with a sum, okay, or a difference. So look at this. You have sine alpha times sine beta. Two different angles. And then this is just the identity, right? You see how, like, there is no need for you to memorize all this. Like, it's just too much. These are things that you don't need as often, and you can just look them up, okay? But it's like the quadratic formula, right? Like, you have to know the quadratic formula to move on. It's not efficient to be looking it up all the time, right? Okay, so here we go. Rewrite this as a sum or difference. Well, this one, if I label these 1, 2, 3, 4, which identity am I going to use for this one? 3, okay? So use number 3. So this is going to be 1/2 cosine alpha minus beta. So 6x minus 3x plus cosine alpha plus beta. Okay? I just plugged it into the identity. That's it. I really haven't done much math.
These will be given, or these are memorized? We can memorize these.
No. Nothing in this lesson do you have to memorize. All will be given to you. But now you just have to like simplify a little bit. 1/2 cosine, what is this? 3x plus cosine 9x, and that's it. You could just leave it like this. You're done. Okay? Isn't that cool?
Yeah.
So there was actually, like, if you look here, no, because they're not the same angle. It's like if you have √3 plus √5, can you combine them? Same thing.
Okay, got it. Because it looks like you'd be able to.
Yeah, you really want to, don't you?
Yeah.
Yeah.
Cosines and x.
Yeah, it's like cosine x.
Yeah. You know what else you can't do? Suppose you had 1/2 cosine 2x plus cosine 6x. You also cannot
Like,
cancel
distribute
those. Yeah.
Okay.
Okay?
That's gonna be so tough.
Because I know it's so tempting because it's like if you had √6/3. Can you cancel those? No.
But if you were multiplying by like 3 over something, you could, right?
If it's not a root, then you can't. Okay. So I used to have like all of this before, right? That I have taken out. So like I've taken out half the lesson this year, only because I didn't feel like I felt like this year we could just stick to the basics. So, But you should really know when to use what here. Now, this went from product to sum, but you could also go the other way. You could go from sum to product. Oh, look, that's what the other identities are called, sum to product. Okay? These literally do the opposite of what we just did in the last problem. Okay, so here we go. Find the exact value of cosine 255 plus cosine 195. Okay, what? These are not even special angles. What are you saying? Then you say to yourself, okay, how do you know what identity to use here? Well, you say to yourself, wait, what is it? Is there a pattern here? What do I have here? I have cosine of an angle plus cosine of a different angle, right? Oh, that's these. That's where I've seen these. Cosine of an angle plus cosine of a different angle. Notice this is not the same as cosine of A plus B like in section 4, right? Okay. So, well, I'm going to use this one, right? Okay. So, this is going to be 2 cosine A plus B, 255, plus 195 over 2 cosine 255 minus 195 over 2. Okay? Something magical will happen here. This is 2 cosine. You know how much this is? 255 plus 195. So that's 260. And then how much? 3. Well, whatever. When you do divided by 2, it's 225.
It's 450.
So is the other one?
225. Cosine, guess how much that one is? 255 minus 195, that's 60 over 230. So this is 2 times. Oh my God. 225, that's a special angle. You know that by its radian name. Where's 225, guys? Here. That's 5 pi over 4. 225, aka 5 pi over 4. Look at you guys. You guys know the radian better than the degrees now, huh?
Yeah.
You didn't even recognize who that was. So, what's the cosine of 5 pi over 4? Negative 1 over root 2. Right?
Yeah.
Yes. Times, what's cosine of 30? Root 3 over 2. Now, I can cancel this 2 with this 2. Negative root 3 over root 2. Which, I mean, you could totally leave it like that. Look at that. Look at what you've done. You just evaluated this. That's like magic, right? Talk about it like a party trick, right? You could totally do that, like, just like, have someone like set you up, right? And be like, hey, give me some random angles. And they're like, okay, cosine of 255 plus cosine of 195.
The song at a party.